Today we are going to be doing analytical geometry. Analytical geometry. So we are going to do the question paper from November 2024. In the diagram below, triangle ACD has vertices A, D, and C, where A is a point in the second quadrant. Then you are told that the point B is -1, K is lying on DC. Then the first part is saying what? Calculate the gradient of DC. You are required to calculate the gradient of DC. So you have to go to the formula sheet. From the formula sheet, you extract the formula for gradient. So the formula for gradient from the formula sheet is saying M equal to y2 minus y1 all over x2 minus x1, whereby here we are having the coordinates of D and we have the coordinates of C. So this one is our x. In this case, this one is our y. When we go there, always remember we write our coordinates in terms of x, y. So we can decide if we say this one is x1, it therefore means that this one becomes y1. And if therefore this one, we are going to have x2 and y2. Then substitute. So it means the gradient of DC will be equal to our y2, in this case it's -9, minus our y1. Our y1 in this case is 0, divided by our x2. Our x2 in this case is 3, minus here our x1. In this case, it's -9. Then simplifying that, just trust your calculator. Then you simplify that. So we are going to have this one, it's -9 divided by 12, which reduces to -3 over 4. But once you have substituted here, you can just trust your calculator so that from here, you go straight to your answer. That is question 3.1. Then we can go to question 3.2. The question 3.2 is saying, determine the equation of DC in the form. So we go to question 3.2. We want the equation of DC. We want the equation of DC. They said in the form y equal to mx plus c. This is the equation of a straight line. So what is it that you need to calculate the equation of a straight line? You need the gradient and any point. So if we are to come and check in this equation on this line, this DC is the one that we did this gradient already. So you choose any point that you want from these two. So if we decide to take this point, it therefore means that we are going to our y, there it's 0, equal to our m. Here we calculated our m to be -3 over 4. Then we calculated our x is given from the point that we decided to use. We take it to be a -9 plus c, because we want to solve for our c. So in this case, you are left with 0 equal to this times this. You can use your calculator. It's going to be 27 divided by 4. Therefore, plus c. Therefore, eventually when you transpose this one to that side, it means your c is equal to negative 27 over 4. This becomes our C. Therefore, the required equation is y equal to m, which is negative 3 over 4, x plus c. Our c is minus 27 over 4. And take note, then this is the required equation. Take note, still on that, it's not, remember we said for us to get the equation of a straight line, we said we only want a point plus gradient. So you can decide to use the other point. Let's check if whether it will work. So it means if you decide you are going to put your y equal to mx plus c. We want to solve c, but in this case, we decided to take this point. So our y is negative 9. Then our m, here is our m, it's negative 3 over 4. Then our x, here is 3 plus c. So you are left with negative 9 equal to negative 3 times 3. We are going to get negative 9 over 4. Can use your calculator. Then we are solving for c, so we are going to transpose that to that side. It's going to be negative 9. If you check that, negative 9 can be written, if we wanted to have a denominator 4, so it's negative 36 over 4. But let us put it this way. Then this one becomes plus 9 over 4 plus, sorry, that will be equal to c, not plus c. We are solving for our c. We transpose that. So this will be equal to c. Negative 9 plus 4, we can use your calculator. Then you are going to get your answer, which is negative 27 over 4 being equal to c. Once you have your c, you just go and substitute y is equal to negative 3. Y is equal to negative 3. X, because the gradient is there, then c minus 27 over 4. Then you can still use another method, because the equation of a straight line can be written in this form. Still, we are still on that question 3.2. The equation of a straight line can be written in this form. M multiplied by y minus y. Sorry. It's x minus x1 must be equal to y minus y1. The x1 and y1 are representing any set of coordinates that we have. So in this case, our m, we know it's negative 3 over 4. Then our x there, if we decide to use this point, so it means our x gonna be negative 9 minus, our x, you take it as it is. So our x is there. Then when we have x1, it's point. So if we decide to use this point, it means our x1 gonna be negative 9. If you decide to use this one, means your x1 gonna be 3. So in this case, if you take this one, it's gonna be minus 9. That will be equal to y minus 0. When you simplify, we have minus 3 over 4, open bracket, x plus 9 equal to y. Then, removing brackets, we have minus 3 over 4 multiplied by x. Then minus 3 over 4 multiplied by 9, we get minus 27 over 4. This is equal to y. then you write in this format that is required. Then the next question is saying, show that k is equal to -6. That is on question 3.3. They are saying show that k is equal to -6. So alternatively, if you check k is a point here and is lying on line CD. So since it's lying on line CD, it means you can just substitute the coordinates of B in the equation. So our equation in this case is y equal to -3/4 x minus 27 over 4. But we have the coordinates of B where we are having K. Here are the coordinates of B where we are having our K. So come and substitute them in the equation here. So our Y is K. So it means your K is equal to -3/4. Then substitute that. It's gonna be -1. Our X minus 27 over 4. You can trust your calculator, get your answer. Here you can see our K is equal to, here times this negative becomes positive. So it's 3/4 minus 27 over 4. Therefore, our K in this case, it becomes this minus this. We are going to get -24/4. It becomes -6. Still there. We can apply the concept of collinear points. In other words, we know that if points are collinear, it means the gradient between n of the 2 points will be equal. So in this case, since B, C, and D, since that C, B, and D are collinear, meaning to say they are lying on a straight line. That is the alternative way for that one. It therefore means the gradient of CD must be equal to the gradient of BD or CD, any that you decide to take. So we can say it will be equal to the gradient of CB. So in this case, our gradient of CD was calculated, and we found the gradient of CD to be -3/4. Then the gradient of CB, we are going to apply the formula here, change in y over change in x. But we have to take note now. So if you decide this one to be your x1, your y1, it means here we will be having our x2 and our y2. So our y2 in this case it's k. So it's gonna be k minus our y1. In this case it's 0 or over x. Here it's -1. Then it's gonna be minus the x1, which is -9. So our -3/4 will be equal to k over, if you simplify, -1 minus -9, trust your calculator, use your calculator, we are going to get 8. Then from here, multiply both sides by 8. So if you multiply here by 8, multiply here by 8. You will be left with here your k. Here, when you simplify, trusting your calculator, you get your -6. Then let's go to next question. It's calculate the length of DC. You are required to calculate the length of DC. That is question 3.4. You are required to calculate the length of DC. So for you to calculate the length of DC, it means we are going to apply the distance formula. Go to your formula sheet. So your distance is equal to square root of x1, okay, x2 minus x1 squared plus y2 minus y1 squared. We have them because we are still using D and C. So it means your distance gonna be equal to the square root of x2 is 3 minus that one is gonna be minus 9 squared plus y2, which is minus 9 minus y. Our y is 0 squared. Then from here, just trust your calculator, punch this one as it is on your calculator, get to the answer. We are going to do here, it's gonna be 12 squared, which gives us 144 plus 81, which is after negative 9 squared, so plus 81. You'd realize that this is the square root of 225. And the square root of 225 is 15. So this is equal to 15 units. But take note, this one, once you substitute, you can just trust your calculator, go straight to the answer. Then the next question is saying you are supposed to calculate the ratio of BD as to DC. So in this case, on 3.5, the distance DC here, so what we has calculated here was the length of DC. So this ratio DC, we already have it, so it means we need DB. So you can just go and, since we have the coordinates of D, so you can go and calculate the length. You are still using distance formula, so we are going to calculate the length of DB. So that's gonna be equal to square root of, in this case, if you check the coordinates of our B here, we got them to be -1. Then that K, we said it's -6. So it's gonna be 3 minus is 3 minus -1. Then plus, here it's -9 minus -6. Then squared. So we are going to get the square root of, here you can just punch that on your calculator, and in this case you can, so here it's 4 squared 16 plus then here we are going to get a 3, a negative, because it will be -9 plus 6 is a 3 squared, so it's gonna be plus 9. So this is equal to root 25, which is going to give us 5 units. Therefore, now to have the required ratio, it therefore means that the required ratio BD over DC will be equal to here. That's our DB. Here, take note, it's DB. Let me write it the way it's written. It's DB. This DB. And we calculated the distance. We found it to be 5 divided by the other one. We found it to be 15. So it means that ratio is equal to 1/3. Then we are on question 3.6. On question 3.6, if M is a point, you are told if M is a point on AC, sorry, on AD, so it means M is a point that will lie on this line, AD. But you are told that such that AC, this is AC, will be parallel to MB, meaning to say we can put the point, it could be here. So in other words, we are saying we'll be having our M there such that this line is parallel to that line. Then the question, calculate the ratio of area of triangle MBD. This is MBD as to area of triangle ACD. So as we can see in these triangles, since we have said these two sides are parallel, okay, let's go. We go to the two triangles that we are given. We go to the two triangles that we are given, this triangle and this triangle. So we are having triangle M, B, D, and triangle. The other one is triangle A, C, D. So if we are to check these particular triangles, we can see that angle D, which is in triangle MBD, will be equal to the angle D from triangle ACD. Why? It's a common angle. It's a common angle in both triangles. Then from there, if you check, we can go to, we can now go to this triangle. Since we have been told that this line and this line are parallel from this statement, AC and MB are parallel, we can therefore conclude that this angle and this angle are equal. So in other words, we are saying our MBD will be equal to MBD, sorry, it's BMD. It's BMD. That will be equal to which angle? BMD. We said is equal to CAD. Why are we saying those two are equal? They are corresponding angles. What is it that we are given? We are given that AC is parallel to MB. Then we can therefore conclude that the third angles are therefore equal, meaning to say the angle MBD, the angle MBD will be equal to angle C. Those ones are, we can conclude because we have already proven that these two angles are equal. So we can conclude that, therefore, those third angles are equal. These are third angles, or we just have to write the reason as sum of angles in a triangle. Sum of angles in a triangle, said, or that. Or you can write it as, because we have parallel lines, this angle is equal to that one. So they are also corresponding angles. You can write them as corresponding angles, and still the sides AC, the lines AC parallel to MB. Since we have proven that these three are equal, we can therefore conclude that the triangles. So we can now conclude that, therefore, triangle MBD is similar to triangle MBD is similar to triangle ACD, because we have proven that, the reason we have proven that the three angles are equal. Therefore, since these are similar and we know the side of this ratio, it means that we can therefore come and say, therefore, that ratio is area of triangle MBD over area of triangle ACD. You just take any corresponding sides. So it means that will be equal to BD over, the corresponding size is DB over DC squared. As long as we have two similar shapes, to find the ratio of their areas, we just have to square the ratio of their sides. So this is equal to, this ratio, we have it already as 1/3. So if it's squared, it's gonna give us 1/9. This becomes our ratio. Right. Alternatively, still on this question, we based on that. So we said we'll be having our, let me remove, we'll be having our M on this side. So we can say maybe our M is there. So here we are having this. So this side and this side is given that they are parallel. So since we already have this ratio here, we can conclude that, let us go, we can therefore conclude that DB, still on question 3.6, we can conclude that DB over DC, that must be equal to DM over DA, and the reason for that is gonna be prop theorem. The reason for that gonna be prop theorem. Proportionality theorem. The sides which are parallel, you are told that you are told that AC is parallel to MB. Then from there, this you got it to be 1/3. So it means, therefore, our DM over our DA will be equal to 1 over 3. If we are to come and put this on our, if we are to come and put this, it means here it's one part. Then here is 3 parts. But here we are not given. This is not the actual length. So to avoid, we can put a variable. So it's gonna be A. Here it becomes A. Then we do the same on this side. Here it's 1. Then here, from the ratios that we are given, is 3. But because it's not the actual length, we put another variable different from the variable that we put there. So it's B. Then here, 3B. Then we go straight from that diagram. We now go straight to this area of triangle MB. We go now to answer the question. Area of triangle MBD over area of triangle ACD. How do we calculate area? Use area rule. So it's going to be half. The angle that we are going to use, we are going to be using this angle since it's common, this angle to both triangles. So we have to use included angle. So it means the sides that we use are these ones. So MBD is this one. So we are going to take the sides, the one which is here, M. Okay, this one is the side which is having 1A, so it's A, multiplied by the side which is having 1A there, it's gonna be a, sorry, this side, we said it's 1B, so we're gonna put a B, multiplied by sine, the included angle there, it's D, all over half the area of the bigger triangle, then this is 3A multiplied by 3B multiplied by sine D, which is the included angle. If we are to check sine D and sine D, we will divide. B and B will divide. A and A will divide. Half and half will divide. So we are left with our numerator is 1. Then our denominator 3 by 3, it's 9. We are getting the same ratio. Then we are done. Then we are on the last part, which is 3.7. There you are given that the gradient of AD is -4. We have the coordinates of D, but we don't have the coordinates of our A. So let the coordinates of our A be X, Y there. So we use that. So it means we need the formula for gradient. What is the formula for gradient saying? What is the formula for gradient saying? So you copy the formula for gradient from your formula sheet. We know gradient is equal to y2 minus y1 all over x2 minus x1. We can take this one as our y2 and our x2. Then this one becomes our x1 and our y1. So substituting, we are going to get our gradient. We are told that the gradient of AD is -4. So we are going to have -4 being equal to our y1. Our y2 is going to be minus 9 minus, we said let it be y, all over. Here our x is 3 minus x there. Then cross multiply, this is the same as over 1. So if we cross multiply, we are left with -4, which is going to multiply 3x minus, sorry, 3 minus x, which is going to be equated to -9 negative y. Then expand there, it's gonna be -12 positive 4x. which is equal to negative 9 negative y. We can make y the subject of the formula. So if we take y to that side, it becomes positive, being equal to, take the x to this side. So we are going to be having negative 4x. We have a negative 9. Take the 12 to that side, it's going to be a positive 12. So this means our y is equal to negative 4x positive 3. This becomes equation 1. Then, the other thing that you are given, you are told that the length of AD is that one. Calculate the coordinates of A. So the reason calculate the coordinates of A, but the coordinates of A were not given. We are only given two conditions. So we are using those two conditions to formulate the equation. So here, use distance formula. The distance formula, we have used it earlier on in previous questions. X2 minus x1 squared plus y2 minus y1 squared. Then you go and substitute. So if we do the substitutions, it means the distance of AD, we are still using our x and our y, the distance of AD. So it's gonna be the distance which we are told it's root. We are told the distance is root 612 is equal to, use the distance formula. So it's gonna be 3 square root of 3 minus x squared plus here y it's minus 9, so it's gonna be minus 9 minus y squared. We have to solve the equation, so it means we have to square both sides. To take note of the radicants, if you square here, you are going to be left with the 612 being equal to 3 minus x squared plus minus 9 minus y squared. This becomes your equation 2. But if we check in equation 1, y is the subject of the formula. So you have to take this y, come and substitute it here. So it means you are going to have your 612 being equated to 3 minus x squared plus minus 9 minus our y is what? Our y is now minus 4x plus 3 squared. So this 612 will be equal to 3 minus x squared plus, we are having minus 9, minus minus, it becomes plus 4x, then then minus, so it becomes minus 3 squared. So this 612 is equal to 3 minus x squared plus 4x minus 9 minus 3, it becomes minus 12 squared. Then we are having 612 equal to, expand that bracket, it's gonna be 9 minus 2 times 3 times that. So it's minus 6x plus x squared plus, here we are going to have, if it's plus, it's So we are going to have 16 x squared. 2 times minus 12 is minus 24. Minus 24 times 4 becomes minus 96. So here it's going to be minus 96x plus 144 for 12 squared. Then simplify. So it means if you take like terms, we can take this one and this one. We are going to get 17x squared. So we are having our 612 being equal to 17x squared. Then from there, we also take these ones with x, this one, and this one. So minus 6 minus 96, it becomes minus 102x. Then you take plus 44 plus 9. So it's going to be plus 153. Then you take this one to this side. So it means your 0 is equal to 17x squared minus 102x plus 153 minus 612. So standard, it means it's 17x squared minus 102x. Then you have to simplify 153. You have to simplify 153 minus 612, which is equal to minus 459. Yeah, minus 459. This is a quadratic equation. I recommend the use of the quadratic formula. So your x is equal to minus b plus or minus. Copy it from the quadratic formula. Don't try to memorize it. B squared minus 4ac all over 2a. Then can you please check our x there? So it means our x is equal to our b is, if you check, let us do it here. From this equation, our a is equal to 17, our b is equal to negative 102, and our c is equal to negative 459. So substitute those values. So we are going to get minus our b minus 102 plus or minus the square root of b is minus 102 squared. So b squared minus 4. Our a is 17. Our c is minus 459 all over 2. Our a is 17. Then you punch on your calculator, trust your calculator from there so that you got your answer. So using the calculator, we agreed our b is equal to, our a is equal to 17, our b is equal to negative 102, then our c is equal to negative 459. So we are getting our answers for x to be equal to x is equal to negative 3 or x is equal to 9. But if you check from the primary statement, we are told that A lies in the second quadrant, and in the second quadrant, the x value is negative. So it means we take this value positive, it means this value is in the first quadrant. So our A is going to take this value. Then from that value, you now have to go and check the Y value. To get the Y value, just substitute this X coordinate in this equation. So it means your Y will be equal to -4. Our X is -3. Plus 3. Then trust your calculator. It therefore means the Y will be equal to this times this is 12 plus 3 is 15. Therefore, the coordinates of our A, the coordinates of our A are going to be -3 and -3 and the Y 15. And please take note here. Let me revisit here. We said this one is positive. The only quadrants where our values are positive, it means it can only be either first quadrant or the fourth quadrant, which in this case, since we want the same gradient, it means this was going to be in the fourth quadrant. Now we are on question number 4. You are given in the diagram, M is the center of the circle. The line cuts the X is at N. The circle cuts the X-axis at N. ST is a tangent to the circle at P there. Then you are given that R is D1 with D greater than 0. Then you are also told L lies on the circle here. O and V are the x-intercept. O and V are the x-intercepts of PL and RL, respectively. This is the information that we are provided with. Then the first part is saying write down the coordinates of L. If we are to check on our diagram, PL is a diameter, and you have to know that M is therefore is a center. M is a center, therefore M is the midpoint of PL. M is the midpoint of PL. So we are going to use the midpoint formula. You go to your formula sheet and copy the correct midpoint formula for our question 4.1. So the midpoint, we are going to write for X coordinates, we say X1 plus X2 all over 2 must be equal to X at midpoint. Then if we are to check, let's deal with X. The coordinates that we have here, X1 and X2, you have to take note, they represent the end points of a line, and this XM is representing the midpoint. And here we are only having P, which is one end point. So it means we can say the P is representing X1. So the X there is 3 plus the X2, we do not know. X2 is representing the X at L over 2 must be equal to the X coordinate at the midpoint, which is equal to 1. Then we have to solve this equation. So when you multiply both sides by 2, we are going to be left with 3 plus X2 equal to 2. Then transpose that one to that side. So X2 will be equal to 2 minus 3. You have to always take note when we transpose, the sign changes, which gives you -1. Then let's do the same for y. So it means y1 plus y2 must be equal to y at midpoint. Here we are having y, so it's 9 plus the y2, which we do not know is the y at L, all over 2. must be equal to y at midpoint, which is 3. When you multiply both sides by 2, you are left with 9 plus y2 being equal to 6. Then your y2 is equal to 6. Transpose this one to this side, minus 9, which gives you a negative 3. Therefore, the question is wanting coordinates. So our final answer must be in coordinate form. So the coordinates of L, therefore, means are going to be -1, -3. Then the next question, determine the equation of the tangent ST to the circle at P. So we want the equation of a tangent here, but a tangent is a straight line. So how do you get the equation of a straight line? You need gradient and a point. How do you calculate gradient? You can calculate gradient when we are having 2 points. We come here on the tangent. We have how many points that are known of certainty? It's only 1 point. So it means we can't use that formula. We can calculate gradient if we know the angle of inclination. Again, we do not have the angle of inclination. We can calculate gradient when we are given conditions. Conditions will be talking of parallel lines, collinear points, perpendicular lines. So if you check, this is a tangent, this is a diameter. So we can therefore conclude that ST, that is for question 4.2, ST is perpendicular to PL or to PM. Why are we saying that? The reason for that is tangent perpendicular to radius. Therefore, it means we have PM here, which is having a complete set of coordinates. So it means we can calculate, therefore calculate the gradient of PM. We are going to use the gradient formula y at P minus y at M divided by x at P minus x at M. You copy the formula from the formula sheet, but here you can now put letters of the so that you don't confuse yourself. So it means this will be equal to y at P, it's 9, minus y at M is 3, all over x at P is 3, minus x at M, which is 1. If you check, you can just trust your calculator, punch that. So it's going to give us 6 over 2, which is equal to 3. When you now have gradient of one line, and you must know the relationship between perpendicular lines. If lines are perpendicular, it means gradient, because we proved that they are perpendicular, gradient of PM here multiplied by the gradient of ST must be equal to -1. So we know the gradient of MP, they are saying is 3 multiplied by the gradient of ST, which is equal to -1. Divide both sides by a 3. So it means the gradient of ST is equal to a -1 over 3. Now you have gradient of ST and you have a point. You can now calculate the equation of the tangent. Therefore, equation of tangent y is equal to mx plus c. So y coordinate, it's 9, equal to gradient, it's -1 over 3. The x coordinate, as you can see there, is 3 plus c. So it means your 9 is equal to -1, because the 3 and 3 will divide, plus c. When you transpose there, it means your c will be equal to 10. Solving the equation, therefore, y is equal to gradient, which is -1 over 3, x plus c, which is 10. This becomes the equation of our circle. Alternatively, when you are dealing with the equation, it means from that part, you are going to use y1, y minus y1 equal to m open bracket x minus x1. Then from there, y minus y1 is from the point 9 equal to gradient, it's negative 1 over 3. Then you have x minus, here x1 is 3. Then we are left with y minus 9 equal to a negative 3x, sorry, a negative 1 over 3, x, a negative, and a negative brings a positive 1. Then you just have to transpose the 9, which is here, to that side. So your y will be equal to a negative 30x plus 10 after taking the 1 to that side. Then find. Then the next question, they are saying show that the equation of the circle with center M is given by this. So we know that the general form of the equation of a circle is 4.3. It's 4.3. We know the general equation can be given by x minus a squared plus y minus b squared equal to r squared. But this a and this b are representing the x and the y coordinate at the center respectively. Then this x and y, you have to substitute any point that is on the circumference. So here we have p, which is there. So it means we can substitute the p to be the x there to be 3 minus the x coordinate at center 1 squared plus y, we know it's 9 there, minus 3, the y coordinate at center squared must be equal to r squared. Then simplifying this, 3 minus 1 is 2. 2 squared, you get 4, plus 9 is 6. 9 minus this is 6. 6 squared is 36. This is your r squared. Therefore, r squared is equal to 40. Then from there, we can write our equation of the circle. It's x minus 1 squared plus y minus 3 squared equal to 40. Then from there, they don't want it in this standard form. They want it in expanded form. There, you expand the brackets. So here, it's going to be x squared. Then here, this 2 times this minus 1 times x. So it's going to be minus 2x plus 1, which is 1 squared. Then plus here y squared. Then minus 3 times y, it's minus 3y times 2. So we are going to get minus 6y. Then minus 3 to the power 2, that one is going to be plus 9. That must be equal to 40. Then simplifying, we are going to have x squared. Then take plus y squared. This one minus 2x. That one minus 6y. Then we are having 1 plus 9. It's going to be plus 10. Take the 40 to this side. It becomes minus 40 equal to 0. Then eventually write your solution. X squared plus y squared minus 2x minus 6y. There it's going to be minus 30 equal to 0. That's the required equation. That's the required equation. Then the next question, what are they saying? The next question, they just said, show that D is equal to 7. Where is our D? D is on R, which is a point on the circumference. So since the point is on this circle, you just substitute the point in the equation of the circle, and you substitute it where you want. Either you can substitute this because it's equation of a circle. So if you substitute it there, it therefore means where there's x, we put D. So it's gonna be D minus 1 squared, D minus 1 squared plus y. Our y is 1. So it's gonna be y minus 3 squared equal to 40. There. Then here we are going to have D minus 1 squared. Then here when you simplify, it's gonna be 4 must be equal to 40. Then from there, take this one to this other side. Take this one to this other side. So it means D minus 1 squared is equal to 40 minus 4, which gives us 36. But we want to take out the squared, so it means we square here, but here it's plus or minus. So it means our D minus 1, the square root and the 2, which is exponent, will be equal to plus or minus 6. So we are left with two answers, D minus 1 equal to positive 6, or D minus 1 equal to negative 6. Then solving, it means our D here is equal to negative, is equal to, when we transpose 7, or our D will be equal to, when you transpose negative 5. But if you check our angle at the value of x is positive, because we are even told that D is greater than 0. Even by looking at the diagram, it's on the positive x-axis. Therefore, D is not this one. We conclude that our D is equal to 7. Still on that question, that was 3.4.4. One would come and substitute those values in the expanded form of the equation. So we are saying to solve that one, you can use this one. You can use this expanded form of the equation. So you substitute where there's x, put D. So it's gonna be substituting there. That is question 4.4. We're gonna say where there's D, where there's x, put D. So it's gonna be D squared plus y squared, but our y is 1, so it's plus 1 squared minus 2x, but our x is D, minus 6y, our y is 1, minus 30 equal to 0. So you'll be left with D squared minus 2D. What's happening? Minus 2D there. Then we have a 1 minus 6, it's minus 5. 1 minus 6 is minus 5. Minus 5. So here it's going to be minus 35 equal to 0. If you are comfortable with factorization, then do the factorization and solve. But I recommend the use of the quadratic formula. So to solve for your D, it's minus B plus or minus the square root of B squared minus 4AC all over 2A. Put the substitutions. Your B, it's negative 2, which is the coefficient of D. Then plus or minus, the B, it's a negative 2, not a positive 2. Plus or minus the square root of B squared, so it's gonna be minus 2 squared plus or plus, sorry, it's minus 4. The A here, the coefficient of D squared is 1. The C here, it's negative 35 all over 2A. The A is a 1. Then you trust your calculator. You are going to get 7 as your D or as negative 5. But as you can see, our X, you are told it's positive here. You are told that our D is greater than 0. Our D is positive. So, conclusion, this is our D. For those who wanted to use factorization, it means when we are here, the factors were gonna be x minus 7, x plus 5 equal to 0. We want two numbers. If we multiply, they were going to give us negative 35. And if we add them, they were going to give us negative 2. So it's negative 7 and positive 5. Then from there, we equate each bracket to 0 to get an x equal to 7 or an x equal to negative 5. But it's given that D here is greater than 0, meaning to say it's positive. So this one does not apply. Then right, we are on question 4.5, and the question 4.5 is saying calculate the size of L. This is L, but if this is the angle that they are saying calculate, but if you are to check, this L is in this particular triangle, and if you are to apply some theorems from Euclid, you see this is a diameter. This is a diameter PL, and we know a diameter subtends an angle of 90 degrees at the circumference. So here it's 90 degrees. So we can just say angle R is equal to 90 degrees. Why? That's an angle in a semicircle, or angle subtended by a diameter. Now, when we are dealing with the right angle, the triangles, we know we can calculate the sides by using Pythagoras theorem, or the angles by using SOHCAHTOA trig ratios. So in this case, we now have the coordinates of R, you have the coordinates of, so you just have to calculate the distance of any two sides that you want. So in this case, we can decide to calculate the length of PR. You can calculate the length of PR using distance formula. So it's gonna be x at P minus x at R squared plus y at P minus y at R squared. Then here is our P. So this gonna be equal to you calculate this gonna be equal to x at P is 3 minus x at R, we found it to be 7. So it's minus 7 squared plus y at P is 9 minus 1 squared. So this is equal to, here it's minus 4 squared is 16 plus 64, which is going to give us root 80. And if we are to apply sets, root 80 gonna be 16 times 5. So this is going to be 4 root 5. We can use your calculator straight from here, then simplify. Then let's calculate the length of any other side. In this case, we can calculate the length of PL. We can calculate the length of PL. So if we are to calculate the length of PL, that will be equal to square root of, so the x at P is 3 minus the x at L, which is minus 1, then squared plus here the y at P is 9 minus the y there, it minus 3 squared. So if you simplify this, this is going to be equal to, here it becomes 144, here it becomes 16. So it's root of 160, which is 16 times 10. So this gonna be 4 root 10. Now, here, if you check, since it's a right angled triangle, it implies this side PL is our hypotenuse. So this one is our hypotenuse, this side. And with respect to this angle, this side is our PR, it's our opposite, and this side becomes our adjacent. So you would use your soccer tool depending on the sides that you would have calculated. But in this case, it means I calculated the opposite, which is the side opposite the angle that we want, and the hypotenuse. Which ratio is opposite and hypotenuse? So we'll say sine L will be equal to opposite, which is PR divided by hypotenuse, which is PL. So our sine L will be equal to 4 root 5 divided by 4 root 10. So your L is equal to sine inverse, this 4 and this 4 and this 4. So sine inverse root 5 over root 10. Then you simplify, use your calculator. Over root 5 divided by root 10. So the final answer is 45 degrees. The final answer is 45 degrees. Therefore, the L is equal to 45 degrees. That is one way you were gonna be able to calculate it. Or if you calculated this side and this side, you were going to be able to get this is adjacent, this is hypotenuse. So this ratio which uses adjacent and hypotenuse, it's cos. It was possible that you calculate this side and this side, which will become the opposite and the adjacent, meaning to say you are going to use the ratio tan. Alternatively, you can calculate the three sides. Let's calculate the three sides, because with calculating three sides, after calculating all the three sides, let's calculate the length of RL. Okay, this is our answer. So alternatively, it was possible that you calculate the length of the third side. So you calculate the distance of RL. When you calculate it, it's gonna be x at R, it's 7. Eh, what's happening with my pen? What's happening with my pen? Okay, let me check. So we are saying x at R, which is 7, minus x at L, which is minus 1. squared plus y at r, which is 1, minus y at L, sorry, it's 3, minus 3 squared. If you are to check, this is equal to root of 80, which is equal to 4 root 5. So if you had calculated all the three sides, we can easily pick, this is the hypotenuse, here it's 90 degrees. So here, this side and this side are equal. Therefore, it means that this angle here and this angle here are equal. These are angles opposite equal sides. So we were still going to get our L being equal to 45 degrees. Another method, depending on the type of triangle that you are given, you are going to calculate all the three sides, then you apply the cosine rule. If you check, how is the cosine rule? The cosine rule says a squared is equal to b squared plus c squared minus 2bc cos a, where a here is the side opposite the angle that we want. So in this case, after calculating these three sides, so it means we're going to put 4 root 5 here. 4 root 5 squared being equal to b. B is now taking the other sides, which is equal to 4 root 5, which is this side, squared plus the other side here, which gives 4 root 10 squared minus 2b 4 root 5. The c is 4 root 10 cos a. Simplifying here, we are going to get 80 equal to 80 plus 160 minus, when you simplify this, 2 times 4 is 8 times 4, 32. So it's gonna be 32 root 50 cos a. Taking this to the other side, here it was gonna be negative 160 equal to negative 32 root 50 cos a. Then you simplify, divide both sides by a negative 32 root 50, divide by a negative 32 root 50. So here you will be left cos a, because this will be gone, will be equal to 32 enters here how many times? It's 5. So 5 over root 50. Therefore your a is, sorry, it's not a here. Our angle here, it's L. Here, our angle is supposed to be L. Let's use the correct angle. It's supposed to be L. So here it's cos L. Here it's cos L. Cos L. Cos L. Here it's cos L. Then here is L. It's gonna be cos inverse 5 over root 50. Then trust your calculator. So cos inverse 5 over root 50, which is still giving us 45 degrees. 45 degrees. So you have to know that for you to be able to answer this question, you needed an understanding of trigonometry. Still, on that question 4.5, it was possible that you can use analytical geometry concept. It's an angle between two lines. So it means you needed the gradient of PM. You needed the gradient of PM, but if you check earlier on, the gradient of PM was calculated to be 3. The gradient of PM, it was calculated earlier on to be 3. We found the gradient of PM to be equal to 3. Then we also have to calculate the gradient of we need the gradient of RL. We need the gradients of those lines making the angle. So the gradient of RL was going to give us what? The gradient of RL. So it's gonna be 1 minus 1 minus 3 using the gradient formula, all over here d we found it to be 7 minus 1. Then the final answer here, we are going to get a 4 divided by 8, which is half. Now, when we have the angle, we need the angles of inclination. So it means angle of inclination, in other words, inclination of PM. It's gonna be tan inverse. You need to calculate that. So it's tan inverse the gradient, the angle of inclination, which was going to give us tan inverse 3 is giving 71.57. That is if you put it to 2 decimal places. If you put it to 2 decimal places, then calculate the inclination of RL. We are talking of the angle, we are talking of the lines making the angle that we want. So we are talking of RL and that one. So that one was gonna be equal to tan inverse half. So shift tan half. When you round it off, you are going to get 26.57. Then, to get the required angle, we are going to say the bigger angle of inclination minus the smaller angle of inclination. So, it means then our L will be equal to what's that? Let me quickly go. It's 71. Okay, before we go to L, let us explain it from the diagram. Let us explain it from the diagram. Don't know the problem with my pen. So let's go to our diagram. Let me use a red ink. So in other words, when we calculate the angle of inclination of PM, this one, which is also the angle of inclination of PL, this is the angle of inclination That's the angle of inclination, and we found it to be 71 point what. Then we calculated the angle of inclination of LN, which is this one. We found it to be 26 point what. 26 point what. Then if you check this angle is equal to this angle here. Then we use the interior angles of a triangle. If we check, we are having this triangle here. We use the angles of a triangle. Then when we produce this one, we will know that this angle plus this angle must give us this angle. In other words, we are saying the angle L that we want plus the angle here, which we are saying is 26.57 degrees, must be equal to this angle here, which is equal to 71.57 degrees. And what is the reason for that? What is the reason for this? It's exterior angle of a triangle. Then from there, we can make L the subject of the formula by subtracting this here. Still, we are going to come to our 45 degrees. Now the last question is saying RT is a tangent to the circle at R. So it means we are having another tangent here. It means we are going to have another tangent there. Then the question is saying prove that PT is perpendicular to RT. Prove that PT is perpendicular to RT. How do we prove? Using the concepts of analytical geometry. For us to prove that those lines are perpendicular, it means we need the gradient of this line and the gradient of this line. But unfortunately, we do not have the coordinates of t for us to be able to calculate this gradient because we don't know this gradient. So it means we have to employ other means. So in this particular case, we are going to go back to Euclidean geometry and apply Euclidean geometry. In this question, we have just calculated this angle and we concluded that this angle is 45 degrees. And this one, we are initially given that it's a tangent. You are told that ST is a tangent. Where is it? ST is a tangent to the circle at P. Here you are told it's a tangent, and this one is a chord. And we know that the angle between a tangent and a chord is equal to the angle in the alternate segment. So we can conclude that this angle is 45 degrees. So in other words, what are we saying? In other words, what are we saying? We can therefore conclude that P we can conclude that P sorry, it's not P. This angle here, it's RPT. The angle RPT. We are saying that angle is equal to the angle LY. It's tan chord. It's tan chord. Therefore, we can say RPT is equal to 45 degrees. Then this other angle here, we can use that. This is a tangent, this is a tangent. These are tangents from the same point. So PT is equal to RT. So we can conclude that PT is equal to RT. Why? Those are tangents from same point. Those are tangents from same point. Those are tangents from the same point. Therefore, then you come to this triangle. Triangle PTN. In triangle PTN, we have concluded that this PT, sorry, it's PTR, not PTN. It's PTR. We have concluded PT is equal to TR. Therefore, we can conclude this is an isosceles triangle. So we can easily see that the angle RPT, the angle RPT, the angle RPT must be equal to the angle PRT, must be equal to the angle PRT. Why? Because these are this angle and this angle, these are angles opposite equal sides. But we have proven earlier on that RPT is equal to 45 degrees. So we can conclude that PRT here is equal to 45 degrees. Still on that P angle PRT, we can use an alternative there. We can come here. This is a tangent. This is a chord, and they subtend an angle in the alternate segment there. So alternatively, we can just say PRT must be equal to the angle L. Why are we saying so? It's tan chord. Because we are given this one as a tangent, then there is a chord there, then the angle between a tangent and a chord must be equal to the angle in the alternate segment. So we can therefore conclude that our PRT is equal to 45 degrees. So we come here, it's proven that it's 45 degrees there. So still in this triangle, PRT, still in that triangle PRT, we can now conclude that the angle RPT, the angle RPT plus the angle PRT plus the angle T must be equal to 180 degrees. Why are we saying so? These are angles in a triangle. But here and here we found them to be 45 degrees each. This angle we found it to be 45 degrees. This one we found it to be 45 degrees. So it means here our T, we make it subject of the formula, will be equal to 180 degrees minus this, taking this one to that side, minus 45. Then you take this one here, take it there, minus 45 degrees. Then the T, it means it's equal to 90 degrees. So the question was saying what? Prove that PT is perpendicular to RT. If lines are perpendicular, it therefore means if there is 90 degrees, therefore answer the question, PT is perpendicular to RT. It has been proven. Thank you.